Hi everyone, welcome to this lecture. So in this lecture, we are going to solve our project 3 on KNN classification. So here I am inside the folder of KNN. This is my project 3. So project 3 is on wine data. So basically we are going to perform KNN classification on wine data in this project. So click on this file so that we can open it in our Google Colab environment. So here I am in my project 3. So for my project 3, I need NumPy, I need pandas, I need matplotlib. Similarly, I need to import k-neighbor classifier from sklearn.neighbors, and I also need train test split. Okay, let's run this cell to import all these important Python modules. Okay, now it's time to get the data. So I am getting the data from datasets. So what I am going to do is I am importing datasets from sklearn, and then from datasets, I am going to load a wine data, and I am calling the data name as a wine as well. Okay, let's run this cell. So I have successfully importing the dataset called as a wine data. Let's see the data. Now here the data is in a different form. That is, if you see, this is the data, and these are the targets. So these are present inside the dictionary. Like you can see that this is the dictionary here, and this is our key, and these are our value. So this data is representing basically the features of the data, and these targets are representing the labels of the data. And we can see that we have three labels: 0, 1, and 2. And based on the three labels, we have the target names as class 0, class 1, and class 2. Okay, the more important thing is we have the feature names. So we have the feature name alcohol, malic acid, and so on. So based on these features, we have the quality of wine. So basically our wine is of three quality. That is, the quality belongs to class 0, class 1, class 2, based on these features. So we have a wine data set, we have a feature, we have the targets. So basically we have three targets. Okay, let's explore this data further. So if I want to see the feature name, I have to write wine.feature underscore name, because I can see here this variable is feature underscore name, and it is inside the wine. So wine.feature underscore name. Let's print the feature name. So these are the same feature name which we have seen here. Okay. If I want to print the target names, so I can see the target names are class 0, class 1, and class 2. If I want to see the data shape, now this is very important. Basically, this is the shape of my features for this data set. Okay, so we can see that we have 178 sample in this data set, and we have 13 features. There are quite a lot of feature in this data set. Let's see the wine targets. So if we see wine target, we have 0 label or target, we have 1, and we have 2. So we have already checked that we have three classes: class 0, class 1, and class 2. Okay, now wine target shape. So since we have 178 features, so we also have 178 labels. Now let extract features and labels. So calling the features as X and label as Y, that is in the standard format. So let's run this cell. So wine.data are our feature. We can also confirm from here the data are our features, and targets are our labels. Okay. So here we have features, and we have our targets. Now it's time to split the data into the training and testing component. Here I am going to use a function train underscore test underscore split. And here I am passing my feature, my label. The testing size is 20%, and random state is 42. Very, very standard stuff. You have seen this many times before now in this course. Let's run this cell to split the data. Now it's time to standardize the data. Here I am importing standard scalar from sklearn.preprocessing. Here I am instantiating my standard scalar, and I'm calling this as a variable sc. Here I am fitting this standard scalar to my training component, and here I am standardizing my testing component of the data. So let's run this to standardize both the training and testing component. Now it's time to find the optimal value of k. So this is very important. In project 2, if you remember that we use two different methods in order to find the optimal value of k, that is using error rate plot and using grid search cross validation. So you can use any of the method in order to find the optimal value of k, because both method we saw in project 2 worked very well and their performance was very close to each other. So both methods are compatible to each other. So here I am using the error rate method in order to get the optimal value of k. You can also use grid search cross validation method as well. So the first step is, here I am creating the empty list for the error rate. I am running the for loop for 50 different values of k. So k is basically our nearest neighbor. Okay, here I am instantiating my classifier. Here I am passing nearest neighbor is equals to I. Therefore, when this loop is run for the first time, I will get the number of nearest neighbor is equals to 1. And for nearest neighbor is equals to 1, I will calculate the error rate. So basically, I am going to calculate the error rate for 50 different values of k, and I will select that value of k for which the error rate has the minimum value. So here I am instantiating my neighbor or my classifier. Basically, here I am fitting my model or my classifier to the training component. Here I am getting the predictions. Here I am calculating the accuracy. And after accuracy, I am calculating the error rate value. And here I am appending the error rate value to the error rate. So this is exactly the same code which you saw in project 2 of KNN. Let's run this cell. And now it's time to visualize the plot of error rate. And here I am getting the plot of error rate. So I have seen that at the start, the error rate is high, then it falls down, then again it gets the highest value, and it is vibrating between the two values. But when it reached to the value which is equals to 28, it has the minimum value for the first time. Later on, it has the minimum value for many numbers of k, but the first time it reached to the minimum value is when k was 28. So based on this observation, we will select the number of neighbors is equals to 28. So with n neighbors or nearest neighbor is equals to 28, I am again instantiating my KNN classifier and I am calling it KNN here. Here I am fitting this KNN to my training component, and here I am getting the predictions from the test samples. Okay, let's run this cell to train and test the model. Here I am comparing the predicted samples from the model with the actual labels of the testing component to get the accuracy. So we can see that again, we have the accuracy equals to 100%. So we have seen that the error rate plot is doing a great job in order to select the optimum value of k. So for nearest neighbor is equals to 28, we are getting the accuracy 100%. Let's plot the confusion matrix for this 100% accuracy. Here I am setting the font and the size for the font inside the confusion matrix. And I am importing the confusion matrix and confusion matrix display from sklearn.matrix here. And here I am getting the image of the confusion matrix. So let's run this cell. So we can see that this is our confusion matrix. So all the samples belongs to class 0, class 1, and class 2 are correctly classified. So they are along the diagonal of the confusion matrix, and we can see that there is no misclassification. So this is the confusion matrix. If the accuracy is 100%, all the values are along the diagonal and the misclassified values are 0. So in this project, we learn how to perform KNN classification on a wine dataset. The wine dataset has large number of features, that is, we have 13 features. Then we select the optimal value of k using error rate. We get the value of k is equals to 28. So 28 was the value of k for which the error rate has the minimum value. And then we perform KNN classification for k is equals to 28. We get the accuracy equals to 100%. And by getting accuracy equals to 100%, we plot the confusion matrix, and we observe that this confusion matrix has the accuracy of 100% because all the values are along the diagonal, which shows the correct classification of the samples, and there is no misclassified sample. So I hope you understood this project. Thanks for listening, and I will see you in the next lecture.